Namaskar and welcome to Pal Talk Statistics. I'm your host, Dr. Chinmoy Pal, and this is the show where we break down complex statistical ideas into practical, everyday learning.
And I'm Ria, your co host. Today's topic is something many students and researchers encounter when working with repeated measures or block designs, the Friedman test.
Yes, the Friedman test. It's a non-parametric alternative to repeated measures ANOVA. It's particularly useful when you want to test for differences across three or more related groups, but your data doesn't meet the assumptions required for a parametric test.
What is the Friedman test?
So, let's start with the basics. The Friedman test is used to detect differences in treatments across multiple test attempts or repeated measures taken from the same subjects.
Right. It's named after the American economist Milton Friedman who proposed it. You can think of it as a non-parametric cousin of the repeated measures ANOVA, wherein instead of using raw data, we use ranks within each subject or block.
It's particularly useful when you have three or more related samples. The dependent variable is ordinal or non-normally distributed, and the data comes from the same subjects measured under different conditions or from matched subjects.
Real-life applications.
Let's take a real-world example. Suppose a teacher wants to compare student performance under three different teaching methods, let's say lecture, group discussion, and interactive learning. She tests the same students after each method.
Now, since the same students are involved in all three tests, the data is related. If the test scores are not normally distributed, or if the data is ranked or ordinal, the teacher should go for the Friedman test instead of repeated measures ANOVA.
Another great example is in clinical trials, where a doctor wants to compare the effectiveness of three different medications on the same group of patients measured over 3 time periods.
How does it work?
Now comes the interesting part. How does it work?
The Friedman test ranks the data within each subject or block. So for every subject you assign ranks to the different treatments. Then it calculates the sum of ranks for each treatment.
Then we compute a test statistic called the Friedman chi-square.
If this statistic is large enough, we reject the null hypothesis which states that all treatments have equal effects.
Here's the formula for the Friedman test statistic.
After calculating the statistic, you compare it with the critical value from the chi-square distribution, with k-1 degrees of freedom.
Assumptions of the Friedman test. Now let's talk about assumptions. Even though the Friedman test is non-parametric and doesn't require normality, it still has some basic conditions. The dependent variable should be measured at ordinal or continuous level. The groups, which are the treatments or conditions, must be related, which is same subjects or matched subjects. The observations must be independent, which is within groups, and there should be no extreme outliers in the ranks.
Also, unlike ANOVA, Friedman test doesn't give you information about which groups are different. For that, you'll need post hoc analysis, like the Wilcoxon sign rank test with Bonferroni correction.
How to report the Friedman test? Let's say you've done the test and found a significant result. How do you report it?
A proper report might sound like this. A Friedman test was conducted to examine differences in student scores under three teaching methods. The results showed a statistically significant difference in performance, chi-square in 2 equal to 7.85, p equal to 0.019.
Very clear and concise. And if you did post hoc tests, you'd also report which groups differed and include adjusted p-values.
Software and tools.
By the way, the Friedman test is easily available in most statistical software. In SPSS, go to Analyze, Non-Parametric Tests, and then Related Samples. In R, use the function Friedman.test. In Python, it's available in SciPy with scipy.statistics.friedman chi-square. Even tools like Jamovi and JASP offer user-friendly interfaces for it.
So whether you're a beginner or an advanced user, it's accessible and easy to apply. Summary. Let's wrap it up. Here's what we've covered. Friedman test is a non-parametric test for repeated measures or related samples. It compares three or more conditions or treatments. It uses ranks instead of raw scores. It's an alternative to repeated measures ANOVA when data is not normal. It requires post hoc testing to know where the differences lie.
It's widely used in education research, medical trials, psychological studies, and marketing experiments, wherever the same subjects are tested multiple times.
That's all for today's detailed dive into the Friedman test. We hope this episode helped you understand not just what it is, but when, why, and how to use it.
If you found value in this discussion, please follow Pal Talk Statistics and share it with your friends, students, or research colleagues. Let's spread statistical awareness together. Stay sharp, stay statistical.